We've covered now all the transformations that are possible for the function y equals x squared. And those would be vertical translations, horizontal translations, and either compressing or stretching the graph. We're now going to take a look at an example where we incorporate all of those possible transformations into one equation. And we're going to be looking at the equation y equals 1/2 times x minus 4 quantity squared plus 2. Now we next would like to determine what specific information we can determine about the graph by looking at the equation itself. And what we're going to do is compare our equation to the general form, which you can see is stated in red. Immediately prior to this example, you read in this module about the information that you can pick out from the general form. Now we first observed that the value of a for our equation is 1/2. Now what does that tell us about the graph? Well, first, because our value of a is greater than 0, that means our graph then will open up. Now second, because the absolute value of our a, which is the absolute value of 1/2, is less than 1, but greater than 0, that will tell us that we will have a vertical compression of this graph as it compares to the graph of y equals x squared. So if we state that formally, we can say that we have a vertical compression then by a factor of 1/2. Now we next observe that our value for h is equal to 4, and our value for k is equal to 2. So this will tell us then that the vertex for our graph will have then the coordinates 4, 2. Now what do these h and k values tell us about translations for the graph? Well, first, because our h value is 4, you can see that we're subtracting a positive constant from x before we square. So that will tell us then that we have a horizontal translation of 4 units to the right. Now because our k value is positive 2, we're adding a positive constant to the squared quantity. That will tell us then that we're going to have a translation vertically upward of 2 units. So we'll then say 2 units up. So now let's take all this information, put it together, and sketch the graph. Now let me suggest an approach for graphing parabolas that I find convenient without having to set up a table with a lot of points. Now what I do first is to locate the vertex, which you can see is plotted here with the red dot at 4, 2. Now next what I'm going to do is to draw in the axis of symmetry, which you know is a vertical line that will pass through the vertex. Now you can see that I set up a table with 3 points. And you'll note that all 3 points will lie to the left of the axis of symmetry. So let's plot those points next. Now to find some other points in the graph, we're going to use what we know about the symmetry of a parabola. Now remember, if you fold a parabola over its axis of symmetry, the 2 halves of the graph will coincide or match up exactly. So if you take a look at the point 0, 10, which is located at the top there, you'll notice that that point is 4 units to the left of the axis of symmetry. So it should make sense then that its mate, if you will be located 4 units to the right of the axis of symmetry. So we can put a point right here. So if the graph were folded over the axis of symmetry, you can see that those 2 points then would fall on top of each other. Now in a similar way, if you take the second point down that you can see is located at 1, 6.5, that particular point is located 1, 2, 3 units to the left of the axis of symmetry. So its mate or partner will be then 3 units to the right. So we go 1, 2, 3 units then to the right to locate its partner. And then for the third point that you see there, which is located to the point then 2, 4, it's 2 units to the left of the axis of symmetry, so its partner will be then 2 units to the right of the axis of symmetry. So now we've got certainly enough points to give a pretty accurate sketch of the graph. So put all these pieces together and sketch it. Now, do you see how easy and fast that was? I hope so. Now let's finish up by answering the questions that we were asked to answer at the beginning of the problem. And we know that the vertex, we've already discussed that, is located at the point 4, 2. The axis of symmetry, the vertical line that passes through the vertex, will have the equation in x equals 4. Domain, as always, will be negative infinity to infinity. Now if we go back and look at the vertex again, you'll note that the y value of the vertex is 2. And since the graph opens up, that will tell us then that all the other y values for points in the graph will be larger than 2. So we can then say that the range for this particular function will be then from 2 to infinity.